Okay, I'm going to be talking about tonight how you figure out the correlation. So, we're going to be talking about correlations of data. So, we have a problem that says a teacher is a assessing the correlation between the teacher is assessing the correlation between the number of hours uh, studying for a test and the score made on the test. The table shows the data. Um, Questions. A. Is there any correlation? Justify your correlation. Write the function that best fits the data. And B. What does the slope and y intercept of the plot indicate? 3 points for that, 3 points for B, and 4 points for A. So, first of all, I'm going to tell you what what type of correlations we have. We have a positive correlation, we have a negative correlation, and we have no correlation at all. So, we have these are correlations. Correlations. We have a positive correlations, and that's when both x and y go up. So they both improve. Okay? Or they both go in this, yeah, they both go up. All right, so a negative correlation is when while x is going up, y is going down. X goes up, y goes down. So basically, and then like there's no correlation, that's when it's just like your graph is kind of all over the place. It is no relation. So I'm going to just show you how the graphs look. So in other words, this is your graph. So the graph looks like this. So let's say, for instance, on the number of hours that you study, these are the hours that you study. So then your test scores go up. The more hours you study, the more the more your grades go up. That's a positive correlation. Here, it's a negative correlation. So this is like x goes up, y goes down, or x goes down. I always get this mixed up. X goes down because x never goes up. I mean, did I do it right? I did it right. X goes up, y goes down. Because x is 1. So this is like 1, 2, 3, 4. So this is x and this is y. So you can just kind of say x never goes down, because then like it would be a negative. So that's over there. So then your graph looks like this. Okay, so then for no correlation, there's no relationship. So there's no relationship between x and y. So then like your graph kind of looks like this. You got your points all over the place. So that's what you can say about correlations. That's what you need to know about correlations right there in order to do this problem, because it says what is the teacher is assessing, so she's trying to figure out what is the assessing, what is the correlation. And so you got to know, what is the correlation. A positive correlation where your x values go up and your y values go up in the same intervals. So it's got to go up at the same time, the same intervals. So x goes up three times each single time. So x goes up by like 3 times. So 3, 6, 9, 12, 15, 18. And y goes up at the same time. We'll say like by 20, 40, 60, 80, 100. Do you understand what I'm saying? So they don't necessarily have to go up. So we'll say that x goes up 3 times each and y goes up 20 times each. So this is a positive correlation because it goes up. And this is a function. So these are some clues. So this is a positive correlation. All right. This is a negative correlation. Your x value is going to be positive. So let's say this goes up every time. For every hour, the temperature is going down. So like for like at 1 o'clock, the temperature is the temperature is just like we in Florida, and it's different here. The temperature is 75 degrees. Then at 2 o'clock, the temperature is 73 degrees. Then at 3 o'clock, the temperature is 71 degrees. Okay? So this is a difference of 2. This is a difference of 2. This is a difference of 1. And this is a difference of 1. Okay, so this x value is 1, right? This x value is 1 because the difference between them is always 1. This y value is -2. -2 because it's going down. It's going down. Do you understand that? So this would be a negative correlation. This would be a negative correlation. And your value, your chart is going down. Your chart is going down. All right? So when it says no correlation, let's just say, all right, we're going to pick 2 kids. Let's say Sharon. Sharon's mom give her 25 cents on Monday. Jerry's mom gives him $1 on Monday. Okay. On Tuesday, did I say Sharon? Her mom gives her 25 cents. So this is the x value, and this is the y value. On Tuesday, Jerry's mom gives him $2. On Wednesday, Sharon has $3. Her mom gives her $3. So, and then on Wednesday, Jerry's mom gives him no dollars. Okay? So, see how that goes from 25 cents, 25 cents. So there is no change there. So that's 0 change. Here, there is $2.75 change. Here, there's 1 change. Here, there's 2 change. So that's different. And that's different. It's just different because there's no correlation. So it doesn't matter how much money, they have no correlation at all, because how much money Sharon moms give her has nothing to do with how much money Jerry's mom gives him. So there's no correlation. So that is the pre-teaching of this problem. Okay? So that's the pre-lesson of this problem. Alright, so I'm going to erase this. I hope you wrote this down. If you didn't write it down real quick. So, while I'm going to go over it again. And like I said, if you didn't write it down right now. A positive correlation is when X and Y go up. They don't have to go up the same amount of time, but they have to both go up. As X value go up, Y value also go up. So that is a positive correlation, and it is a function. When something goes up the same time every time, that is a function. As X goes up, Y goes up. That is a function. That you might be like the rise of a run kind of thing. If you remember that. So these are correlations, or if you've gotten to that point yet. A negative correlation, as X goes up, Y goes down. Those are negative correlations. As X goes up, Y goes down. And your graph looks like it's going down. Okay? It's going down. All right. So the non-correlation is X has nothing to do with Y. So like on Monday, Sharon's mom gave her 25 cents. On Tuesday, she gave her another 25 cents. On Wednesday, she gave her $3. So one day, how much money she gave her has nothing to do with the next. So how much money Sharon's mom has nothing to do with how much money Jerry's mom gave him. Okay? So those are non-correlations. They don't have no relations with each other at all. All right. Now, I'm going to read you the question again. I'm going to read the question again. And then I'm going to kind of put it over to the side. And I'm going to answer the question. But there is another clue to this. There's another clue to this. There is a big clue to this. The question says, a teacher is assessing the correlation between the number of hours studying for a test and the score made on the test. The table shows the data. Okay, now this is the biggest clue ever. That's not the biggest clue. Is there any correlation justify your answer? And your answer is going to be positive. There is a positive correlation, because as X values go up by X amount of points, by so many points each time, then Y goes up by so many points each time. Or your answer is going to be yes, it's a negative correlation, because as X goes up so many points each time, Y goes down by so many points each time. Okay? Or your answer is going to be no, because X goes up by this time, and then it goes up by this time. So it goes up by different amounts each time. So those are the problems. Those would be your answers, your sample answers for A. Now, B and C are your biggest clues that there is a positive or a negative correlation. Because if there were not a correlation, then you would not have to answer B nor C. B says write the function. If there was not a correlation, then there would not be a function. If there were not a correlation, then there will not be a function. So your answer is going to be either a positive correlation or a negative correlation. B has given you a big clue for your answer to A because it says write the function. There is a function that best fits the data. And they give you a whole 3 points. So then it says, what does the slope and y-intercept of the plot indicate? If that is the case, they would not ask you that. They would not ask you that at all. So therefore, you're going to have either a positive correlation or a negative correlation. So I'm going to write, I'm going to go ahead and write I'm going to move this down a little bit, but I'm going to write the number of hours studying. The number of hours studying. Okay. And the scores. Okay. So we got 0 hours. When they made 0 hours, they got like wait a minute. They got 0, they got 30 points. 0.5, they got 40 points. 1 hour, they made a 50. 1.5, they made a 60. 2 hours, they made a 70. 2.5, they made an 80. 3 hours, they made a 90. And 3.5, they made 100. Okay, so that is the table, the number of hours and the scores on the test. So, if they didn't study at all, they made an F. If they only studied for 30 minutes, they made an F. They only studied for an hour. And this does not mean that they had to study for like that hour in one day. I would suggest that when you study for a test, I learned that when I studied for a test, I would study a little bit each day. And then like on that last day, I would go over everything that I needed to refresh my memory. So, A says, what is the correlation? Or is there a correlation? Well, how do I find out is there a correlation? Because this is X. I forgot to put X. This is X and there's Y. Now, how do you find out the correlation? What you do is you subtract. So you find, so I do 0.5 minus 0. And that is 0.5 minus 0 is 0.5. Then I do 1 minus 0.5. And that's 0.5. Then I do, so this is what I'm doing. I'm subtracting these two. Or finding the difference between each set of terms. So, now I got 1.5 minus 1. And that is 0.5. 2 minus 1.5. And that is 0.5. So, 2.5 minus 2 is going to be 0.5. 3 minus, so I believe it is safe for me to assume that all of my answers is going to be what? 0.5. So I'm going to assume that my x term is 0.5 because every time it's going up by 0.5. Okay, so now let's look at my scores. So these are my hours, my number of hours. Okay, so now let's look at my scores. All right, so now I'm going to subtract my scores. So 40 minus 30 equals 10, right? 40 minus 50, 50 minus 40 is 10. 60 minus 50 is equal to 10. 70 minus 60 is equal to 10. 80 minus 70 is equal to 10. 90 minus 80 is also equal to 10. And 100 minus 90 is equal to 10. So again, my y, so my x value is equal to 0.5 and my y value is equal to what? 10, not 100, 10. Okay? So it says, write the function that best fits the data. So, what is my function? My function is, how would I write my function? How would I write my function? My function is, your function is y equals mx plus b, y equals mx plus b. That's function. Okay? That would be your function. So b is y equals mx plus b. All right. So so we have 10. Okay, we have x equals what? 0.5. Y equals what? 10. So what we have to do is we have to find the slope and we have to find the y-intercept. But that's number 10. That's C. Y equals mx plus b. What would be a good function for this? Now, we have done, I don't know if we've done the point slope formula or not. I don't know if you have or not. But I'm just going to assume that you have. Okay, I'm going to assume that you have done the point slope formula. No. The 2 points formula. Okay, I'm going to assume that you have 2 points, that you know how to find a function using, well, right down here at C, it says, what does the slope and the y-intercept of the plot indicate? So this is the slope. M is the slope and B is the y-intercept. Since we got to find that anyway, I think we should go ahead and take 1 point and use it. Why not? So these are our points. Our x, y, this is a point, 0, 30, 0.5, 40, 150 is a point, So these are all points, right? So this is C. This is C. And you can't see C. You can't see C. Can you see it now? Let me see. Yeah, I think you'll be able to see it. Okay. So we're going to use, I'm going to use an easy point. I'm going to stay away from my decimals. I'm going to use 0.030. And I'm going to use 0.150. Because I don't want to use the decimals if I don't have to use my decimals. Okay, so these are my these are my 2 points, right? Okay, so to find my slope, I need to find my slope because I haven't finished this yet. So I'm gonna do kind of B and C at the same time. I haven't finished C yet. I haven't finished B yet, but I've used X and Y. Or let's do this. Can I do this like that? I don't have no I can't. So let's go ahead and find my slope. I'm going to use this to find my slope. When I find my slope, I will have my y-intercept. And then I can answer C. Okay, so this is my 2 points. So this is x1, y1, x2, y2. So my formula to find my slope is y2 minus y1 over x2 minus x1. So y2 is 50 minus 30. And x2 is 1 minus 0. So that is 20 over 1. So my slope is 20. Okay. My slope is 20. All right. So my slope is 20. Okay. So my y-intercept. So now I'm going to plug that in to my m is 20. Okay.